and welcome to Evolution Part 2. Okay, so basically we're continuing on, and one thing that we want to start off with is that individuals are only interested in helping themselves, and selfish behavior. Now, when we talk about that you're only interested in helping yourselves, we're talking about biologically in terms of your genes. You're only interested in helping your genes. And what do we want our genes to do? Get to the next generation, right? Okay. So altruistic behavior, and altruistic behavior is selflessness, like, I will throw myself under the bus for you. I'm selfless, okay? So when we see what can be considered apparently in nature, if you see altruistic behavior, where you think that a member of a species is, giving up their life for another member of their species, we can always explain this as being consistent with the Darwinian theory. Remember that nothing is done for the good of the species according to Darwinian theory. You're only interested in helping yourself, which includes, when we talk about ourselves, we're talking about our genes. So think about what would happen to a gene that created this altruistic behavior, okay? So if animals, it's hard to, take human stuff out of our behavior, but we'll be able to put that back in to see. But for right now, just think about what would happen to a gene for let's say in rabbits, okay, if the rabbits were jumping in front of a predator to save a fellow rabbit from getting attacked, okay? So what would happen to that gene if it was genetic? It would probably get weeded out, okay? So how can we explain this apparent altruistic behavior? Well, let's think, for example, about honeybees, okay? So honeybees, when a honeybee stings you, okay, what happens to it? It dies, right? A honeybee can only sting you once, because when it stings you, the sting pulls out like their intestines, so they're going to die. And when do honeybees, when do they sting? When do they go, when do they feel, why do they do that? It's when their hive is threatened, okay? So when the hive is threatened, that's when the honeybees will sting you to get you away, to protect the hive. And you think, well, wait a minute, isn't that selfless behavior? Isn't that altruistic behavior? Well, we got to look at the situation a little bit more objectively. Okay, so this is introducing the kin selection hypothesis. Altruism should never be genetic, or else that gene would eliminate itself, okay? Because they wouldn't survive, individuals with that wouldn't survive to pass that gene on. So if you see a parent altruistic, if you're a biologist, then you're going to be like, let's step back and let's spend some time examining this situation, okay? And basically, biologists explain that if your kin, your relatives, okay, benefit from your action, your selfless or altruistic action, it's not genetic altruism. Let's apply this back to the bees, okay? All right. So, the worker bees are the ones that'll sting you, okay? They're the ones that fly around and they're going, collecting pollen to bring it back to the hive so that pollen, the nectar can be made into honey, right, to feed the hive. So worker bees do not reproduce, okay? But they can help their genes make it to the next generation by protecting the hive. Because what makes up a hive? Mothers and sisters, right? The mother and the sisters. So in a hive, they're all related because there's only one queen bee, right, that lays all the eggs. Some of the eggs become worker bees that don't reproduce, but they're relatives. They are kin to the others, okay? So in this case, biologists do not consider protecting the hive with your life altruistic behavior, genetic altruism. You might think, but wait a minute, I heard that lemmings commit suicide, okay? Well, I'm sorry, you heard wrong, okay? Lemmings committing suicide for the good of the species goes against the natural selection theory, because again, nothing is done for the good of the species. It's for the good of the individual. So you think, you might ask, well then why can you observe lemmings, why do they go drown themselves or fall off cliffs when their populations get too big? And you do see this out there. You see that when a lemming population gets too big, then lemmings have been observed going out into rivers and drowning and falling off cliffs. Is that suicide? Let's look at it a little bit more closely. So why do they appear to commit suicide? So there's some lemmings. Aren't they cute? Okay. Anytime that you have a population get larger, then they're going to eat more food. They're going to diminish the resources in that area. Okay? So what are they going to do? They're going to look for more food, right? So most creatures migrate when food supplies are low. Okay? Think about herds of animals. When the grass starts to get too low, they move on. They migrate to find more grassy areas. Now, this is the same with lemmings. And then lemmings also have really poor eyesight. They're legally blind, okay? These lemming deaths that are observed are purely accidental. Okay, so when the lemming population gets big and they start diminishing resources in their area, they migrate. The population migrates. In this migration process, some of them die accidentally because they all have really bad eyesight. All right. Note that migration behavior would not exist if it hurt more than it helped, as natural selection would have eliminated that genetic behavior to migrate when you're running out of food. Well, what about altruistic behavior extending beyond your kin? Okay, so far the kin selection hypothesis talks about how if you are being selfless towards somebody that is your kin, putting yourself at risk for somebody that is your kin, it's not altruism, because you're sharing genes with them. So by helping them, you're actually helping yourself. Okay, good for the individual, because you're helping to get the genes that you share with them to the next generation. Well, what about extending this behavior past your kin? So let's see what happens in vampire bats. In vampire bats, okay, again, these are the bats that feed on blood, okay, animal blood. It's very hard to locate a host, okay, every single night. So a lot of times vampire bats will return to the cave hungry. They didn't get enough food, or they weren't able to find a host to feed on, okay? Bats are kind of like hummingbirds in the fact that they have really fast metabolism. And because of that fast metabolism, if they don't feed every day, they'll die. So if they don't feed, more than 2 days back to back, they're going to die of starvation because of their high metabolic rate. So why do we see this cooperation in vampire bats? Okay, so it has been observed in vampire bats that when a hungry bat comes back to the bat cave and didn't get, find a host, so it didn't get enough food for that night, it will go to a bat that did. That's their non-relative, and we'll see that the satiated bat, okay, the bat that has a full stomach, will regurgitate and let the hungry bat, feed on that regurgitated blood. But even though they're not kin, and you think, well, wait a minute, that's not the kin selection. Well, look at it a little bit closer. They will do this. The non-relatives will do this behavior, but it's not selfless because they expect the favor to be returned later. It's kind of like, sure, I'll lend you $20, but I expect you to pay me back or to lend me money when I need it. Okay? This is called reciprocal altruism. And in keeping with natural selection, it should only happen if it's good for the individual, right? Okay? So it has to be good for the non-relative bat to do this behavior to keep in accordance with Darwinian theory. Okay, so what has to be required for this reciprocal altruism? Well, the species must be able to differentiate between individual members of the population, okay? Who their kin are and who their kin are not. They also have to be able to remember that, like, yeah, remember I lent you money 6 months ago? Yeah, I need that 20 bucks back now, okay? You got to be able to have a good memory for that. And you have to punish the cheaters, okay? If there's no punishment, if there's no consequence, it's kind of like with my 5 and my 6-year-old, okay? If there's no consequence to the behavior, then they're going to keep doing it, okay? So the bad behavior is not going to stop, okay, if it's not punished. So the species must punish the cheaters. Now, what do we mean by cheaters here? We mean that the bats, the hungry bats that came back, that got fed, if they don't return that favor in the future, they have to be punished, okay? So this behavior did not evolve because it was beneficial for the group, but rather because it benefited each member of the population that exhibited the behavior. So basically, if that cheater bat, okay, that was fed when they were hungry doesn't reciprocate, then all the other bats go, hey, you know what, you're a cheater because you came back hungry and we fed you, and now we're hungry, or that guy's hungry, and you're refusing to feed them. So guess what? We're going to punish you. And how do you think they're going to punish them? They're going to refuse to regurgitate for that bat in the future that was a cheater. So what's going to happen to that cheater? It's going to die. It's not going to pass on that gene. Okay, so you can see now how this reciprocal altruism is good for the individual, okay, to have this behavior. Okay, so you want to see a bat feeding, okay, so a vampire bat. All right, so here it goes. I got to do some little finagling here.
Here are some happy vampire bats.
So cute.
What's causing all this giddiness? A great big fat meal has arrived. You can practically hear these bats going, oh boy, oh boy. Better yet, the victim is asleep. This is going to be like, well, taking blood from a sleeping pig. The bats have heat sensors in their noses. This thermal process lets us see what the bat sees. The bat wants to feed where the pig's skin glows white hot. Let the dining commence. Like two wildcatters fighting over a fresh oil strike, these bats battle over a particularly rich feasting spot. 4 vampire bats, 1 sleeping pig. Why doesn't the pig wake up? Because the bat's teeth are razor sharp and cut painlessly. The bats can sip to their heart's content, with the pig none the wiser. The bat's saliva actually prevents the blood from clotting. As the bat sips, the blood runs up a groove on the underside of its tongue. Mother Nature thinks of
So they're not
everything.
even sucking the blood. What they're doing, they're like a dog lapping it up.
These vampire
Like,
bats can feast for a full half
so it's
hour,
kind of funny.
drinking half their weight in blood. In a month of feedings, 5 vampire bats can guzzle almost a gallon of pig's blood. In this case, it's the bats making a pig of themselves, not the pig.
That one's funny. That one's funny. Okay. Back to the PowerPoint. Okay. Alright. Back up here. There it is. Okay, so when the video talks about a bat drinking half its weight in blood a night, okay, how much do you think a little bat weighs? Maybe 2 ounces? So, it's not that much. Alright. So I'm going to pause the video here and then continue on. So make sure you watch the next video. I'm trying to keep them shorter, like just 10-minute segments.